Hello and welcome to another Tycho video. Yesterday I had the opportunity to capture an image sequence of the Peregrine Lunar Lander. So today I thought I would put together a quick demonstration on how I processed that particular data set. Now there are of course numerous different ways that you can process such data, so just keep that in mind. I'm just showing one of potentially several different approaches that you could take. But the first step typically is if you've not already calibrated the images, you would do that first. And then next, we can go ahead and proceed to do plate solving. So these images have already been calibrated. So I'm going to go ahead and perform plate solving. So I go ahead and click Start here, and it is going to plate solve the reference image. And once that has completed, the next step is to do alignment. So here it has found a plate solution, and we give it a moment here to complete that operation. So plate solution has been found. Now we go ahead and do alignment, and I click OK. Just for a bit of background information, there are 150 images in this data set. They are each 20 seconds in duration for a total exposure time of 50 minutes. And the total time from the start to last image is about 1.4 hours. So at this point we have completed plate solving and alignment. So now we can go ahead and go to Action, View Images, and this will show us what we are dealing with here. So if we do not know where the object of interest is in this field of view, there are a couple of ways to approach that. One of which is if it is a very bright object, then you can actually just do a stack of the images using maximum as the stacking method. So if we do selection all, it will create a stack of all of the images. Of course, you'll notice right away there's a very bright streak here. That is not the object. However, if we zoom in a bit more, you can see a few other interesting streaks, and this what looks to be a curved object here. So this is actually a set of, again, 150 images been stacked together. So you've got this motion. It has a very definite non-linear motion. So that actually presents a very interesting challenge here as well, both in terms of tracking the object in the crosshairs as well as measuring the object, especially if you want to create a measurement from a stack of images. So I also mentioned, or I should also mention, that another approach, if this were not a bright object, then another way to potentially find it is to attach ephemeris. In fact, there are even more methods than just these two, but if it is a known object and it has ephemeris, then you could attach it from these two sources, for example. So in this case, we could use JPL Horizons. If we did not know its target identifier, we could look it up here. So this will go to their database. You can query the object by name, for example. So I could type in Peregrine, and here we have a result returned, and here's the target identifier. But if I wanted to, I could simply right-click and say Apply Target ID. And all that does is it simply copies that identifier here into this field over here. So now that we have target identifier, I could attach this ephemeris to the data set. And of course, it does that based upon the current active observatory that you have specified. So it's using the latitude, longitude of the observatory that acquired these images. So with that in mind, you can scroll all the way to the rightmost column, and it presents a bit of information there as well. The rightmost column is it expected to be within the field of view? So it's always nice to see when it says yes, so that's always encouraging. Other columns here, you've got the speed of the object, the position angle, altitude, and so forth. Those can also be useful. So the thing is, this is actually one of, in fact, it's the very first time I've ever seen an object not centered in the crosshairs when I use JPL Horizons ephemeris. So as you'll notice, if I wanted to, I can click on an image here. Again, no object. But if you'll notice, as I zoom out a bit, there's something that seems to kind of tag along with the crosshairs. It's not quite centered, but indeed that is the object of interest right there. So this tells us that, again, and this is the first time I've ever seen it, but for various reasons, the object, of course, is not where it has been predicted to be. So this is going to make this video potentially even more interesting, because how can we deal with that? Well, a couple ways, and I'm going to present one way in which we can approach that is we can actually create a custom ephemeris. So what I'm going to do is I'm just going to create a few measurements here. I can create an observation here. So those two terms are somewhat synonymous, measurement or observation. So when I create some measurements, this will allow me to, again, create a custom ephemeris that I can then attach to the data set. So I'm just going to create a few more here. And again, I have to know what that offset is. If you wanted to, you could actually measure what that offset is. For example, you can right click and choose create marker, and I create another marker here, and we basically get a measurement, and it shows up right here. The distance is 38.5 arc seconds. So if you are curious to know how far off the predicted position the object is, you could easily do so, creating a couple of markers. But anyway, I'm going to finish up the measurements I'm creating here, and that will again allow me to attach a custom ephemeris to the data set. So at this point I now have 7 measurements, and this is of a single target. So I go ahead and click add to target list. If I wanted to, I could give it a designation, but for this exercise I don't really need to give it anything special. I click OK, and now that I've done that, I can select these measurements, view them, and then here I can choose compute orbit. So this is going to invoke the Find Orb software, which is really great at taking in a set of measurements and computing an orbit. And from that we can then attach to the data set, much like we did before with JPL Horizons, but in this case we're doing it with an orbit that has been established from our own measurements. So now the hope is that when I click on an image in this data set, hopefully the crosshairs will be centered on the target. And as you can see, they are. So now I can do an animation. So I went to animate, 100 millisecond as the interval. And so now you can see we've got the target tracked nicely in the crosshairs. Now, another thing we could do if we wanted to, we could also create that line segment of start image to the last image. And that can allow us to see how much deviation there is in terms of it having that nonlinear motion. So if it were traveling in a straight line, then it would be traveling along this green line segment. But again, as you can see, it does have a fair amount of nonlinear motion. So that also poses, as I said before, another interesting challenge in creating stacked measurements. Because typically when you create a stack, you're doing so with an assumption that it has a linear motion. So for example, if I were to create a stack from markers, that won't produce anything of interest. Even if I do, of course, a median stack here, what that looks like, we don't get anything of interest. However, if I were to do a stack with Ephemeris, then it will actually take into account the nonlinear motion of the object. So for example, if I wanted to, I could measure what the SNR of the object is on a single exposure. So you can go to object profile here, and you can see it has an SNR of about 16 on that image. Here it has an SNR of 7 on this frame here. So as you know, as most people know, when you create a stack, it will have an improved signal to noise ratio. So if we wanted to, we could create measurements from our stacks here. So I can choose the first 10 images and then right click, choose create stack from Ephemeris. And as you can see, it has an improved SNR of 26 in that example. If I wanted to do one more here, and again create Ephemeris stack, and in this case it has an SNR of 30. So it's a nice improvement from what it was in a single exposure. And I could double click on it, choose create an observation, and again do that same process I did before, but this time from a set of stacked images. So anyway, that's about it for this video. I just thought it might be interesting to some to know, again, one of potentially several different ways to process this kind of data. So Thank you for watching, and see you next time.